Okay, this is A.REI.6 Algebra, Reasoning with Equations and Inequalities 6, Video 2, Solving Linear Systems by Substitution. Here are a few terms to know. I'd like you to write these down in your journals and define them. Today we're going to be taking two equations and two unknowns, and we are going to be using a process called substitution to find the solution to these simultaneous equations. So we're going to be putting two equations on a graph. We could be taking two equations and solving mathematically, and there are going to be a few more methods that we are going to use in the upcoming weeks to find out what a solution could be to these equations. And I'm going to finish off this flip chart with a real world example in which you might use these different processes to do that. All right, so for today, we're going to be using this idea of substituting into the equation. The last video we did, we solved by graphing two lines and seeing where the two lines intersected, and that intersection point was called the solution of the system. Let's see how this method works today. Having our two equations, equation 1 and equation 2, and our two unknowns, are x and y in both of them. We are going to solve for one of the variables in one of the equations. So it doesn't matter which equation you choose. I am going to choose the equation that is going to have me do the least amount of work to get one of the variables isolated. So I'm looking at equation 1, and I see that I have a coefficient on the x of 1 and a coefficient of 2. On the other equation, I see two coefficients that are larger than 1. I believe that solving for the x in the first equation would give me the least amount of work, and it'll take me the least amount of time to solve for it. So if we are thinking about our inverse operations, I'm going to isolate the x on the left, and I'm going to take this term 2y and I'm going to put it on the other side, and we change the sign when we do that, add 7, and we have isolated the variable x in equation 1. Now, thinking of the idea of substitution, we're going to take this value right here, this negative 2y plus 7, and we are going to substitute it into the other equation where we see the x. So that will look like 3 multiplied by the quantity of negative 2y plus 7, and then we have the rest of our equation called negative 2y is equal to 5. So there is our substitution. We isolated one of the variables. We have this quantity of negative 2y plus 7. It substitutes into the other equation where we saw x, and now we are going to do some solving. We have our distributive property. All right, keep going. Let's get our y variables together. So we have negative 6y minus 2y. That's negative 8y. And still we need to solve for this variable y, so we need to take this 21 and bring it over to the right. So we're going to have to do the inverse operation, so we're going to subtract 21 from both sides. So negative 8y is equal to negative 16. And get rid of the negative 8 coefficient. Inverse operation will divide. So y is equal to positive 2. So if I'm looking for an intersection point, I know that my y value is going to be positive 2. Now I need to figure out what my x value is going to be. Knowing that y is 2, I can go into either equation and substitute in my value of y so that I could figure out what my x is. So x is equal to -2 multiplied by my y plus 7. So I just took my y equals 2 value and I substituted in right here for the y value because I know if I do my math it's going to spit out my x value. So x is equal to -4 plus 7 and x is equal to +3. So my final answer would be the solution called 3, 2. If I were to graph these two lines on a grid, they would intersect at the point called 3, 2. And what that really means is that 3, 2 would work if I put it in here and if I were to put it in my second equation, 3 and 2. You did the math and both of these equations would solve correctly. Substitution. Problem 2, I'd like you to pause the video and give this one a try. All right, we're back. Looking at both of these equations, I have some variables that have coefficients and some that don't. So you can either pick equation 1 and solve. I'd probably solve for x here because of this 4. And then in the second one, I'd probably solve for this y because I can take this -x and make it positive on the other side. So it's really a choice right now. I think I'm going to go with the second equation, solve for y. So let's stabilize the y. Take the -x, throw it to the other side, it's positive. And now we are going to substitute y is equal to this quantity of x minus 7. So we have x plus 4 times, so let's substitute in our y value. Our y value is x minus 7, and that should be equal to -8. All right, distributive property, 4 times x and 4 times -7. Okay. X and 4x is 5x. Add 28 to both sides. All right, so -8 plus 28. We're going to come up with a +20. Divide both sides by 5. So we know that our x value is going to be equal to +4. And now we're going to substitute in, now that we know what our x is, we'll substitute it in the other equation. So y is going to equal my new x value 4 subtracted by 7. So y is equal to -3. And we have a solution to the system of equations. These two lines will meet at 4, -3. And you could go check that by substituting this ordered pair into your two equations. And I threw a graph up there to show you that we would be meeting at 4, -3. So 1, 2, 3, 4, 1, 2, -3. And that would be the intersection point of your two lines. If you want to go and put both of these into slope-intercept form and graph them, you'll see that the line runs through this point called 4, -3. All right, here's that problem I was talking about at the beginning of the video. It's a little intimidating, actually, if you read it. It says, for extremely cold temperatures, an automobile manufacturer recommends that a 70% antifreeze and 30% water mix be used in the cooling system of a car. how many quarts of pure 100% antifreeze and a 50% antifreeze, 50% water mix should be combined to make 11 quarts of a 70% antifreeze and 30% water mix? Wow. We are going to use this idea of setting up two equations and two unknowns. So the first equation is going to be your basic sum of the two different types of fluids that need to combine to make 11 quarts. So equation 1 will look like this. X plus Y must equal 11. So we're taking the first liquid solution. We know we need to add it to the second liquid solution, and that sum will give us 11 quarts of a liquid solution. Now we need to figure out the percentages of each of our unknowns to make a 70% solution of the 11 quarts. So extracting the information from the problem, I know that I'm going to take 100% of the first solution and add it to a 50-50%, so 50% antifreeze water solution. We'll multiply that by our second value, our second unknown, and that total, when we put it together, the 100% and the 50% mix must equal a 70% total of means multiply, of the 11 quarts that we need. So if I were to take these percentages, it'll be a little easier to use them as decimals. I don't think we'll be using a calculator, so let's change these percentages into decimals. So we drop the percent sign and move the decimal 2 times to the left. So we're going to end up with 1x plus 50% would be 5/10 y, and that is going to equal 7/10 of the 11 quarts. So now I can eliminate this pink line, the second pink line on the page. All I did was I transferred these percent signs into decimals. So I'm going to just erase that right now because we don't need it anymore. We've just made it look a little different with the bottom equation. And now we have set up our desired two equations and two unknowns. We can A, graph them using our slope-intercept form, or what we're working with today is this idea of substitution. All right, so what would we like to do? What looks to be the easiest in terms of the substitution? I think we'll take the first equation and let's just solve for that x value. So if I'm solving for x, I'm going to have, let's do it over here. X is equal to, we'll take the y value and throw it over to the right. So we're going to have 11 subtracted by y, or if you want to put the y first, you can have negative y plus 11. And we can quantify that. So now that we know what x is, we'll substitute that in. We'll say x is 11 minus y plus 1/2 y, and that's going to be equal to, we have 70% of the 11 quarts. Now, does anyone know what 70% of the 11 quarts is? All right, if not, we come off to the side, and I want to show you a little review on how to multiply decimals. So 11 multiplied by 7/10. We go columns. 1 times 7 is 7. 1 times 7 is 7. we have a placeholder, we have a 0 and a 0. We add up our values, and we have 0, 7, 7 in the bottom, but we need to make up for this decimal in the problem. There was one decimal move, so we have 7 and 7/10. Okay, let me erase that. I know we're going to need some room here. All right, so now we need to combine like terms. We have a -1y, and to that we are going to add a half of a y. So I like to write this out on my paper. So we have -1. If you think about it, we're at -1 on the number line, and to that we are going to add 1/2. All right, so if you're on -1 on the number line, and we know that this is 0 and this is 1, if I'm at -1 and I need to add a half, I'm going to go to the right a half of the way. Where are you going to be? Well, you're going to be at -1/2. So we have 11 minus 1/2 y is equal to 7 and 7/10. All right, now subtract 11 from both sides. Just for time purposes here, let's get out that fancy calculator of ours. So now we have 7 and 7/10 subtracted by 11, and that's going to give us -3 and 3/10. So -1/2 y is equal to -3 and 3/10. Divide both sides by -1/2. And let's figure out what y is going to be. So we have negative divided by negative is a positive, so we can go 3.3 divided by 0.5. That's going to give us a positive 6 and 6/10. All right. Now we're going to take our y value and plug it into our equation that we isolated x for, and that would tell us what our x value is going to be. So we have x is equal to 11 minus our 6.6, substitute in for y, and we're going to end up with, I believe that's going to be 4 and 4/10. So x is equal to 4 and 4/10. Now, if I were to put it as an ordered pair, I'd have 4 and 4/10, 6 and 6/10, and if you think about what that means, let's go back into our original equation and say, okay, this x value up top was the 100% solution. So I am going to need 4 and 4/10 quarts of the 100% solution mixed with 6 and 6/10 of the 50-50% solution to equal a 70% solution of our 11 quarts. How about that? In your journals, I'd like you to define the given terms on page 2 of the flip chart. Write a few sentences on what you learned from this video. If you have any questions, bring those questions to class. And all of those fun word problems that we have in our book, especially with these mixture problems, we're going to be using 2 equations and 2 unknowns, and the processes of graphing the 2 equations on a grid, substitution, and more different processes to solve these types of problems, and those are coming up soon. See you in class.